Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is merge case sorted list. So let's first try to understand the problem, and after that we will see the approach. Okay, so see, you are given a array of k linked list. Each linked list is sorted in ascending order. Okay, merge all the linked list into one sorted linked list and return it. Basically, in this problem statement we have given k sorted linked list. Okay, k sorted linked list, and we have to merge all the linked list, and after that we return one linked list that contain the merge of all the k linked list, and also we have to return the list in the ascending order. Suppose if I consider check this test cases, then in this case test cases we have three linked list. That is, one is 145, and second is 134, and third is 23. And after merging all these linked list, we have to return this linked list. Okay, so let's try to understand this problem statement in the whiteboard. Okay, so basically in the problem statement we have given three lists. In this problem statement we have three lists, but in the problem it is says that we have k list. K has some constant. See, k has constant like k value is lie between 0 to 10 to the power 4. Okay, so let's see. So k value is lie from 0 to 10 to the power 4. Here k is equal to 3. So the our approach behind solving the problem is that suppose see the output of this 3k linked list. So first we take the minimum of these three. Okay, so 1, after that 1 is again minimum, and after that 2 is minimum, after that 3 is minimum, and after that 4 is minimum, again 1 4 is minimum, again 5 and 6. So we have to return this linked list. So our initial thought process behind solving this problem is that if we merge two linked list at a time, and after that whatever the result we get be merged from third linked list. Suppose if I take this thing, so if I merge 1 4 5 and 1 3 4, so for merging of both linked list we take two pointer. Okay, we take two pointer and check whether if here both are equal, to take any one of the list, and after that which one we take, move that one, and after that we check in both of case which one is a smaller. So one is a smaller, to take that one. After that we increase the pointer to here. After that again check which one is a smaller, take the smaller one and move the pointer to the smaller one, and after that check which one both are equal to, so take any one and move here. So this pointer is null. When one pointer reaches the null, then whatever the element rest in the second list, we have to just copy paste that element using with the help of while loop. Okay, after merging these two lists, merge this list with what the get till now. So after merging this two list again, then we get the desired result as 1 1 2 3 4 4 5 6. So this is the basic approach of solving this problem, and it takes uh, time complex it takes very large time complexity. So it may possible that if you try to submit this approach, then it will give the TLE error. So let's try to understand the optimized solution of these things. Okay, so see, basically these all list we have given are sorted, so take the advantage of that cases. So whatever the minimum element we get from all the k linked list is at the index 0 because all the lists are in sorted order. So minimum element from these k list will be lie at the 0 index. So how to find which element is a smaller? So if I take a mean heap has property that it always contain the minimum at the top. It always contain minimum element at the top. Okay, it has property of mean heap. So what if we store all the first element in the mean heap, then it may goes like these things. Okay, so we store all the first element of the each list, because we are very much sure that whatever the minimum element is lie at the zeroth index. So the zeroth place element are put it in the priority queue, and after that we take the top element, because top element gives the minimum among all the k's element, because this goes up to k. Here k is equal to 3. So we take the top element, we take the top element, and after that see whether the top next exists or not. So here if I consider top next, so if I consider top next, so top is the one. If I consider this one, then top next is equal to 4. Yeah, 4 exists, then push it in the priority queue. Push it in the priority queue, and this one will be removed from the queue. And after that, B rearrange itself in such a way that the minimum among these elements lie at the top. So one will be shifted to top position. Okay, so in the next iteration we do same thing, that pick the top element and connect with the link list, and after that we remove this top element and check whether the next of this right element exists or not. Yeah, here if consider this one to next exists, to put it in the priority queue. Okay, and after that we rearrange these things, these three element in such a way that the minimum is occur at the top position. So here the minimum is 2. So if I rearrange this, so the minimum occur as 2 position and 3 4. So minimum is 2. So we take the top element from the priority queue and also pop from the priority queue and check whether the 2's next exist or not. Yeah, next exists 6. Here we see 2 next is equal to 6. So 6 will be pushed in the queue, and after that these three element rearrange itself in such a way that these three lie above, because this is the minimum. So these three lie above, and after that uh, connect with the connect the link with the 3 and remove these 3 as well, and after that check 3's right exist or not. Yeah, here see 3 is next, sorry, 3 next exists 4. So push the 4 in the priority queue, and after that we rearrange these three element rearrange in such a way that the minimum is occur at the top. So minimum is 4. So push link this 4 to the linked list, and after that remove this 4 and check 4 next exist or not. So here you can see that the 4 next is null, so nothing we will do, just move forward. And after that these two element rearrange itself in such a way that the 4 occur at the top, because 4 is the minimum and 6 is the maximum. So in the next iteration we pop this element and connect with the link, and after that check whether 4 next exist. Yeah, so here 4 next is equal to 5 exist. So push it in the priority queue, and after that we remove this 4 value, and in the next iteration we take the top element and connect to the linked list, and after that check pop this element and check whether the next of 5 exists or not. So here the next of 5 is equal to null, so nothing we will do, just move forward. And after that we pop the 6 and connect with the link, and so now the linked list become empty. Sorry, linked list nahi, priority queue become empty. Then at this point uh, b come up out from the while loop, and after that b return this linked list in this head in the answer, and we get this linked list. So basically, if I summarize this problem, then in this problem we take one linked list, sorry, one priority queue of priority queue, that is min heap. Min heap has property that at the top of the element it always contains the minimum value. Okay, we have uh, also think that if the all the k sorted linked list is in ascending order, so what the minimum element of the sorted merge linked list is always occur at the zeroth position. So put this zeroth position element in the priority queue so that we get the minimum at the top position, and we make this list. I hope you all guys understand the approach behind solving this problem. So let's to see this try to see the code of the problem, and after that we will submit the code. Okay, so see, as I have discussed in the second approach, that we take a priority queue, and after that push all the first index or head of all the list to the priority queue. Okay, so see, here we first take the how much list exists. It means that here n is also made as k. So here, if I consider this example, then here n is equal to 3. Okay, so take a priority queue of min heap. Min heap, we take a comparator function. This is the syntax of writing comparator function, because it takes two list L1 and L2, and after that whatever we wanted to return, we return at this position. Then we take the comparator function. Okay, and after that we run a loop from 0 to n. 0 to n, it means that here 0 to 3 is not included. So we run a loop and check whether the list of I not is equal to null. It may happens that, see, check whether this will be null or not. So if not null, then push it in the queue. So one will be pushed, and after that again one, and again two. So push it in the priority queue. So take a dummy node, and take a dummy node of zeros, and it takes dummy node because it may happens that the head will also not made. So in order to made new head, we do this kind of things. Okay, and after that also take a cursor that move again and again. Okay, so while a priority queue not empty, then take the top element, that is current, and after that pop take the minimum will be 1, because 1 will at the top position. And after that, if current connects, so 1 connects is equal to 4 exist. If exist, then push, and after that cursor next is equal to current. Cursor connect, suppose we take 0 as a dummy node. Okay, 0 as a dummy node, and after that what I did, uh, cursor is also pointing to the dummy. Cursor is also pointing to the dummy. Cursor next is equal to top. Current is equal to 1, and after that we move cursor here. Okay, cursor is here, and in the next iteration we do same thing. Cursor next is equal to current, and after that cursor is next plus plus, and so on. And after that, in the end we return dummy next, because dummy is pointing to the zeroth position, but we have to return from here. So dummy is pointing to this position, so we have to return dummy next. And after that, so I hope you all guys understand this code as well, and if you try to submit this code, then you will get the correct result. So let's try to submit the code, and after that we will see whether it will be accepted or not. So see, if I run the code, then it will be accepted, I think so. Yeah, it will be accepted. And if you try to run for all the test cases, then yeah, it will be accepted for all the test cases. So I hope you all guys understand this problem statement. See you in the next video. Thanks for watching the video. Okay, bye.